Hello everyone. Today I'm going to show you how to include domain restrictions in your graphing. Let's get started. Alright, so here you can see I have graphed this line in blue. It's y equals 2x plus 5. You can see it has a y-intercept here at 0, 5, and its slope increases the values of y up to for every 1 that the x moves over. So you can see it's got this sort of up to over 1 up to over 1 pattern. Now, if we wanted to include a domain restriction, what we would do is we would put something like this, as you can see on the second line right here. And you can see it's the same equation, so if you look, they're actually the exact same. However, the second one has a domain restriction, and I want you to see that it's actually the same. They're actually overlapping in here. So you can see it's in the same spot. Now, that's because it's the same line, and if I change these values, what I'm changing are the starting value and the ending value of the x. So you can see here I'm starting from x equals 0 all the way to x equals 1, and that's it. I'm going to stop at x equals 1. So let's see if I change this to something like -2. You can see that it now starts all the way over here at -2, and it proceeds all the way up until x equals 1, which is what we have here. If I change this to 0, right, you can see I'm sectioning off parts of the graph. And so that's basically what you're doing when you're graphing with domain restrictions. You only want to include the part of the graph that follows from whatever the restriction is. If I got sometimes if you get rid of all of this altogether like this, as long as x is greater than -2, as we see here, then I can graph it. That means I'm not going to graph where x is less than -2, but I can graph where x is greater than -2 forever. So I would actually, if I was graphing this, I'd put an arrow if it leaves the graph paper. Okay. Same thing works the other way. So if x is less than a number, like let's say less than 3, you can see the graph only exists up to 3, but doesn't go past 3. It only exists when x is less than or equal to 3. And with that, you now know how to include domain restrictions in your graphs. I wish you well on any assignments that you do that require this. This will come into play a little bit more when we start talking about piecewise defined functions, absolute value functions. They really rely on having that well-defined domain so that we can determine which sections of the graph go where. But we'll talk more about that later.